Well. We all use AI every day to follow instruction, write this, code that, plan my trip. But have you ever wondered how a raw language model actually learned to follow those commands? Today we are going behind the curtains. We are going to take a pre-trained model and fine-tune it ourselves using Python and Hugging Face. So let's get into the code. So this code is a classic pipeline for supervised fine tuning. You are taking a model that knows how to chat, like this is a dialogue GPT model, and teaching it how to follow orders using a specific dataset. So first of all, we will import some libraries. Transformers, the industry standard library by Hugging Face for working with large language models. Auto tokenizer, auto model for casual LLM. These are the classes. Auto classes automatically detect the correct architecture based on the model name which we have provided. In this case, GPT-2 base architecture. Trainer and training arguments, high level tool that handle the complex math of backpropagation and hardware management so you don't have to write manual training loops. And we have load dataset, a utility to download and prepare data from the Hugging Face hub. So first we need data. We are using the OpenInstruct v1 dataset, but there is a catch. Models don't naturally know what an instruction in versus a response is. They just predict the next word. So this load dataset function fetches a dataset where each row has an instruction and an answer. Look at this preprocessing function. We are merging the instruction, the input and the output into one long string. We are essentially telling the model, hey, when you see a pattern like this, the last part is the answer. And this is the most important step. GPT models are casual, meaning they just predict the next word in a sequence. By merging the instruction input and output into one single string called prompt, we teach the model the pattern. Like when I see a request, I should provide this specific answer. Then in this function, we are using a map method which will call this function preprocess function to each of the rows. Now over here, first we shuffle the dataset and we select 1 lakh random samples to make training faster. And we are using this 10 test split, so we keep 10% of the data hidden from the model during training to test if it actually learned or just memorized. The computers don't read English, they read numbers. We use tokenizer to chop our sentence into tokens. We are using DialoGPT medium from Microsoft. It's small enough to train on a single GPU but smart enough to hold a conversation. And over here, pad token, that is equal to EOS token. GPT model don't naturally have a stop or padding token. To make all sentences the same length, we tell it to use the end of string EOS token to fill the empty spaces in short sentences. And this is the function that will be used to tokenize the text. So this tokenizer object will convert the text into the tokens, that is the numerical representation of that word or the text. And when truncation is made to true, that time if prompt is longer than 128 words, that is the max length specified, that is 128, then it cut it off to save memory. Then we initialize the model, meaning we create an object from this class. And in this piece of code, when MLM is made to false, which stands for masked language modeling, since GPT is an auto-regressive model, it look forward, not filling in blanks. We set this to false. We will learn about masked language modeling in our future videos. Now for the engine room, this training arguments block is where we set the rules. We are defining the batch size and the number of epochs, how many times the model reads the entire library. Then we initialize our training arguments like number of epochs that we need. We are keeping it as 1 for just the simplicity and to train this model as fast as possible to save some time. If you keep more epochs, then model will be more accurate, perform better, learn better. So it's better recommended to keep the epochs to a specific number so that it won't get overtrained or undertrained. Because of this epochs, the model will look at every piece of data exactly once, as we have kept epoch as 1. And keeping batch sizes means how many example the model sees at once before updating its brain. And based on your hardware specification, you can make the configuration in this training arguments, like how I have made this. But there is a limitation, it will take much of the time to train the model. And a pro tip, if your computer starts sounding like a jet engine, you might want to lower the per device train batch size. We are running this for 1 epoch today just to prove the concept. And the second last step, we will put all that thing together by specifying the model, training arguments, training dataset, test dataset, and data collator. This is where the magic happens. The model makes guesses, calculates how wrong it was using the loss function, and adjusts its weight to be better next time. The training is done. Now we put it to the test. We are writing a generate response function that moves our model to the GPU for lightning fast answer. So firstly we will take the model that we have trained and saved in our local file. We get it and we create a function to generate a response. So firstly the tokenizer.encode turns your question that is provided, that is the prompt that is provided, into numbers. Then model.generate is where the model starts predicting the next number one by one until it hits the max length. And this piece of code is a neat little trick. It finds the last period in the response and cuts off any unfinished sentence so the output looks clean. Now look at that. It's not just guessing words anymore, it's actually attempting to provide a structured answer based on the instruction format we taught it. Fine tuning is the bridge between a generic AI and a specific tool. You can use this exact same code to train a model on your own journals, your company's documents, or even a specific coding style. This code is in the description. Go build something cool. Don't forget to like, subscribe, and I will see you in the next one.